Okay, so we are finishing up example 2 very quickly. I wish we would have been able to finish it on the previous recording, but it didn't happen. So just to kind of go over it again, pick up where we left off. We got an object moving on the xy plane. If you remember, it gave us x prime of t, but not y prime of t. And we had the initial condition. It was at the point 3,5 when t equals 2. So we were on the very last part down here, part D. It said for all values of t greater than or equal to 3, the line that's tangent to the curve, so the tangent line, has a slope of 2t minus 1. Find the acceleration vector at time t equals 4. So we kind of began with the end in mind, which when in doubt, start with the end and work backwards and figure out what you need to make it happen. So we needed to figure out the acceleration vector at 4. That's the same as v prime of 4, which of course is the same as the second derivative of our positions at 4. And we said that finding x double prime of 4 would not be a big deal because we actually know what x prime of t is. So let me catch up because I think I've been kind of messing around on the calculator. Got to go back to parametric mode. And maybe it's still in there. If you go to y equals, yeah, so it's still in there as x. So I still have that. And I'm in radian mode. We were doing degree mode earlier today. All right, so finding x double prime is not going to be a big deal. I can just find the derivative of whatever I have in x sub 1. But how am I going to find y double prime of 4 if I don't have the equation for either y or y prime? Well, I have to use this piece of information. So this, remember, 2t minus 1, they said is the slope of the tangent line. What's the slope of the tangent line? What's another name for it? dy dx. Right, good. And so that's the same as y prime of t over x prime of t, or dy dt over dx dt. Well, which of those do we know? We know x prime, yeah, is 2 sine of t squared. So I can call that 2 sine of t squared, and I can leave y prime of t, y prime of t. I don't know what it is. And of course, that's equal to 2t minus 1. So now, do I have a way to find the equation for y prime? Essentially, yeah. I can just solve for y prime of t by multiplying both sides by the denominator. So it becomes 2t minus 1 times 2 sine of t squared. And now I can evaluate that derivative, if I need it, at 4. So let's go ahead and do, let's complete the parametric equations. Over here in y sub 1, I can type in 2t minus 1. And then you can just type in times 2 sine of t squared again. Or you could just recall it as x sub 1 if you choose. This is not that difficult to type in. So now I'm set. Now I have my x prime and x, and I have my y prime and y, and now I can go back to my home screen, and I can evaluate the derivative of each of those at 4 and simply plug them in. So here we go. Flush. There we go. Flush. So alpha trace number 1. Oops, I need to do what first? Sorry. I don't want to evaluate the function. I want to find its derivative. So math number 8. Yeah, and we'll take the derivative with respect to t because we're in parametric mode. And now I'll recall it, alpha trace number 1, and we'll evaluate it at 4. And I'll write that down. So you can't see me writing it, but I am, to 3 decimals, 15.322. And now I'll do the second one, math 8 once again, with respect to t. And I typed it in. So you could have just typed it in here instead of going and typing it into y sub 1, but what the heck. And then at 4. And you hit enter, and you write it down, negative 108.408, and you just trust the work. It seems like kind of a large number, but that's the answer. And that right there, again, is a typical free response. So you're always going to have enough information to find what you need. Sometimes you just kind of have to put the puzzle together and figure out how you can do that. All right, so that was kind of nice because it did use the parametric version, which is just dy dx, and kind of relate it to the vector version. All right, so any questions then on parametric derivatives or parametric integrals? Arc length is the same as what? Not displacement, but distance traveled. Yeah. So just remember that there's two parametric or vector quantities that are single quantities. The distance traveled, of course, which is the arc length, and the speed, which is the Pythagorean theorem, the magnitude of the velocity vector. Everything else we represent as two quantities. Okay, so that's it. We'll start